Good day, everyone. So, in today's lesson, we shall be looking at measurement of distance, or sometimes what we call measurement of length. At the end of this lesson, we'll be understanding the tools and techniques that is being used to measure distance from simple strings to a precision micrometer. So, let's dive into this. So, firstly, let us know what a distance is. Distance is simply defined as the extent of space between 2 points. So when you measure the space between 2 points, then you are measuring what? Distance. So there is need for accurate instrument to be used to measure distance, and this is what we are looking at today. Also, the SI unit for distance or length is meter. Okay, this is the international system of units that is acceptable in the whole world, right? So it also has other unit like kilometer, millimeters, and so on. But the SI unit of distance or length is meter. All right. All right. Let's talk about the four key instruments that we use in measuring distance or length. The first one is the string, the flexible string for measuring curves. Then we also have the meter rule. Meter rule is a straight flat marking, that is between 0 to 100 centimeters in length. Then we have the vernier caliper that is within accuracy to be 0.1 millimeters or 0.01 centimeters. Then we have the micrometer screw gauge that has its own reading accuracy or least count to be 0.01 millimeters or 0.001 centimeters. So these are the four key instruments that is being used to measure either distance or sometimes we call it length. So we're going to look at it one after the other. Starting with the string. In the past, in the past years before our own era, when men or when human beings need to measure length, they don't know what is called this millimeter of a thing and all that. So you get a string, just like something like this, and then you want to measure distance from one curve to the other. Okay, you get a string, and then you extend that string to you get to the point where you want to stop. So you now take that string and place it on a meter in our own time now. But in those days, you just take note of the length of that string and that's the measurement. Okay. So, but for the sake of accuracy, if you want to see use that method today, you need to get that string and place it on a meter rule. Okay, what we call our ruler. Okay, you place it there to get the exact measurement that that string has gotten. Okay. So depending on how precise you want to be, this string is not really going to give you a precise measurement because it is not calibrated. You cannot really know the exact number that it's giving you. But mostly we use this kind of instrument to measure curve. Okay, if you want to measure the curve of a garden, as you could see here, then you cannot use a straight ruler, of course. So the next instrument that we can also use to measure distance is called the meter rule. The meter rule extends from 0 to 100 centimeters, just like your ruler. The ruler we use, we had one of 10 centimeters in length, one of 15 centimeters, even the one of 30 centimeters. But we call it a meter rule when the length is up to 100 centimeters. Okay, its own reading accuracy is 0.1 centimeter, the least it can read. Okay, we call it least count or reading accuracy. All right, so we use it to measure the length of a table, the length of a field, and anything that is straight. You make use of meter rule measure. All right. So the next one, the third one, is called the vernier caliper. The vernier caliper is also an instrument for measuring distance or length, but it measures smaller distance than that of a meter rule and a string. So a vernal caliper can measure a distance that is smaller, too small for a meter wheel to measure. And the advantage of this vernal caliper over meter rule is that it does not only measure external distance, it can also measure internal distance. So when you're looking at measuring internal distance of an object, the best instrument to use is the vernier caliper because it is made to measure both external and internal distance. Okay, and it makes use of this of two jaws. It has two jaws. Look at it. This is an example of the vernier caliper. So this is this jaw up here. There you could see you have upper one, and you have a downward. So the upper one is for measuring the internal distance between 2 points of an object, while the external jaws is used to measure the external distance. Okay, so you make it of the jaw up if you are interested in measuring the internal distance of that object, and then you use the down one if you are going to measure the external. So maybe you have a cylinder and you want to measure the internal distance. Okay, you cannot use a meter wheel to measure the internal distance. So you need something like this. So in summary, the vernal caliper majorly is used for measuring the internal distance of objects such as cylinder or a tube. Okay, maybe a test tube. Okay, and they also use it to measure the thickness of a coin. You use this to measure the thickness of a coin. Its reading accuracy is 0.01 centimeters or 0.1 millimeter. This reading accuracy is also called least count. Okay, and you say least count, that the least it can measure or the reading accuracy. Okay, now there is a technique on how to use the vernal caliper before you can use it to measure an object. If you don't know how to use it, you might not get the exact value you want, or you might not measure correctly. So how do you use the vernal caliper? Let's say that this is the object, you have placed the object in the jaw, and then you want to now get the reading from the calibration. How do you go about it? All right, now very simple. The calculation form vernal caliper look like this. The vernal caliper has two scales, the upper scale and the down scale. Okay, so this one now is the upper scale, while the down between 0, 5 to 10 is the down scale. Okay, so we call the down scale the vernier scale. We call the up scale the up scale. We call it the main scale. So, for example, maybe you have taken your vernier caliper and you have taken a reading. You have taken a reading and you want to know what the reading is about. How do you go about this reading? Look at it. You have two scales. How do you go about it? Very simple. The first thing you do is to go to the main scale. That's the upper scale here. Go to the upper scale and note the last division. When I say division, I mean this straight line you're seeing. So the last division that comes before the division of the vernier scale. See, this zero, the down zero here is for the vernier scale, while the up zero is for the main scale. Now the last division that comes before the first division of the vernier scale is this one, and that is 0. Okay, so for the main scale now, the main scale reading is going to be 0. It's going to be 0.0 centimeters. Supposing you have 3 here, let me say, for example, maybe you have 3 around this side. Let's say you have 3. Maybe instead of having 0, maybe it is 3. Then automatically the main scale will be 3.0 centimeter. So the position, the number of that division before the vernier scale is what you take note of. But now, our own case now, it happened to be 0. So we are going to record 0. Okay, so we are recording 0 because the main scale is having 0.0 centimeter. All right. So then the next stage is now for you to know the vernier scale reading. The vernier scale reading is the down part. Okay, the down divisions here. Now, how do you know the reading? For you to know the reading of the vernier scale, you have to locate the division of the vernier scale that coincide with the division of the main scale. You see, the division here, this first division is not coinciding with the main scale. The second one too is not, when I say coincide, it's not meeting it. They are not touching directly on each other. So the one that touch directly on each other is this particular one. And that's the sixth division. You know, this is 0, 1, 2, 3, 4, 5. So this is sixth division. So the sixth division of the vernal scale is the one that coincides with the main scale division. And so we now multiply that sixth division by the reading accuracy of vernal caliper, which is 0.01. So 0.01 times 6 will give us 0.06 centimeters. All right. So you now, the final reading will now be vernal scale plus main scale. Remember, our main scale we have obtained to be 0.0. Vernal scale is 0.06. So 0.0 plus 0.06, that will give us 0.06 centimeter. So the reading on this scale is 0.06 centimeter. All right. Now, that is how you make use of the vernal caliper and the calculation aspect. So the last instrument that you use to measure distance or length is called the micrometer screw gauge. Okay, the micrometer screw gauge is different from the vernal caliper because it's in its own concept. You have to keep turning the plunger. As you turn the plunger, then the jaw will hold the object to be measured. But our concern is we need to know the reading accuracy. The reading accuracy for micrometer screw gauge is 0.01 millimeters, or in centimeter it is 0.001 centimeters. And the micrometer screw gauge is the most precise instrument, that can give you a precise measurement. All right, what do you use it to do? You use it to measure thickness of paper or the diameter of a hair stamp. Imagine the hair of your head, you want to measure the thickness of it. This instrument will measure it for you. Imagine the paper, how flat a paper is, you want to measure the thickness. This micrometer screw gauge will also do that. So it measures very small length or small distance. All right, and just like the vernal caliper, the micrometer screw gauge also require that you do a little calculation before you can get the measurement. Look at this now. This is how the calculation aspect look like. Okay, just like the vernal caliper has the main scale and the vernal scale, the same thing for micrometer screw gauge. It has the main scale too and the vernier scale, but we call the vernier scale the circular vernier scale because you have to turn that scale before they can read. Now, how do we go about this reading? This is a micrometer scale that have been used to measure an object. Now you have something like this. How do you go about it? The main scale is the one that is here, while the one that is vertically written is called the vernier scale. The main scale now, how do you take the reading? Note that we have 0, then 1, 2, 3. First of all, the main scale is usually in millimeter, unlike vernal caliper that the scale is in centimeter. So micrometer main scale is in millimeters. All right. So here, to get the main scale, you just count the number of division you have. This is 0. This is actually 0.5. The middle one here. This is 1, 1.5, 2. Down here is 2.5. Then it's 3. So we have 3 millimeters at our main scale. That's the last division before we get to the vernal scale now. This is it. So this is 3. So our main scale here is what? 3 millimeters. Now the next thing is to now get the vernal scale. The vernal scale are all the readings here. Now, how do you get the vernal scale? The line on the main scale that coincides the vernal scale, you see here, this is it, this line here. And this is 20, so the 21st division is the one that coincides with the straight line of the main scale. And that's our vernier scale. So that 21st division, multiply it with the reading accuracy of micrometer scale, which is 0.001 centimeter, but in this case we are dealing with millimeter. It's going to be 0.01 millimeter. So multiplying 0.01 millimeter by 21, we'll be having 0.21 millimeters. Now final reading will now be main scale reading plus vernal scale reading. That will be 3 plus 0.21, and that will give us 3.21 millimeters. So this is how you go about calculating your micrometer screw gauge result after using it to measure an object or that of vernier caliper too. All right. Now, among the four instruments we have mentioned so far, the most accurate one to use is the micrometer screw gauge, while the least accurate is the string. That's the summary. Okay. So the degree of accuracy is determined by the instrument being used. Okay. The one that is best, the one with the highest degree of accuracy is micrometer screw gauge, and that of string is the least one. However, depending on what you're using it for everyday measurement, it's better you use meter rule, okay? But for engineering and scientific work, the best to use is the vernier caliper and the micrometer screw gauge. Let us see some questions on this topic in JAM. Look at this question here. It said, which of the following represent the correct precision if the length of a piece of wire is measured with a meter rule? Now we have 35 millimeters, we have 35.0 millimeters, we have 35.00 millimeters, and we have 35.01 millimeters. Now the reading accuracy for the reading accuracy for meter rule is 0.1 centimeters. Okay, 0.1 centimeters. But if you are going to leave it in millimeters, it's going to be 1 millimeter. So it has on the decimal point. So in millimeter, the best one is 35 millimeters because it has no decimal point. All right. So it's a whole number. It's going to be in whole number. So A is the correct option. Yeah. The rest are in decimal numbers, so they cannot be used. All right. So the next question says the inner diameter of a small test tube can be measured accurately using a micrometer screw gauge. Now, micrometer screw gauge is anything internal or inner. Micrometer screw gauge cannot measure that. The only instrument that can measure the internal part of an object or the internal distance of an object or inner part, inner diameter is the vernier caliper. Okay, pair of divider cannot do that. Meter rule cannot do that. The only instrument that can do that is a pair of vernier caliper. All right. And we also have another one here. It said the length of a piece of glass block was measured by means of a vernier caliper as shown above. So the length of a glass block is what? Okay, we have learned how to measure using vernier caliper. So here, the main scale is the one up, the vernier scale is the one down. Now the last division before the main scale is this division here. Okay, so if this is 1 and this is 2, then it will be 1.5 here. So the main scale here is what? 1.6. Okay. From there, we have main scale to be 1.6. While the vernier scale will be the one that coincide with the main scale. So the fourth one here. You see it here. This is 1, 2, 3, 4. It's coinciding with 2 here. That will be 4. 4 times 0.01. That is 0.04. Now 0.04 plus the main scale, which is 1.6. So 1.6 plus 0.04, that will give us 1.64 centimeters. Okay, so just adding the main scale to the vernier scale. Main scale is 1.6, vernier scale is 0.04. Adding it up together will give us 1.64 centimeters. All right. So at this junction, we'll be doing the cutting for today. I hope you've been able to learn something about measurement of distance. Thank you for listening and bye for now.